Hello. Hello, Divyanki and Eva. So we were discussing variation in acceleration due to gravity when we are going uh, above the Earth's surface. Are you getting my voice, Divyanki and Eva? So this is the Earth, and this is a body, or this is a mass here at a height h above the Earth's surface, and here the acceleration due to gravity is this, because acceleration due to gravity when we go above the Earth's surface will change. So this is the value of acceleration due to gravity. Okay, and further we solved it, and this is the value of acceleration due to gravity on the surface of the Earth, means here. So finally we got this formula: G dash is equal to G 1 plus H by RE. So you should know what is G dash, what is G, what is H, what is RE. So G dash is the new value of acceleration due to gravity here, and H is the height above the Earth's surface. RE is the radius of the Earth, and G is the acceleration due to gravity on the surface. Okay. Now further we will solve it, and before that I want to tell you something. This H by RE, this H divided by RE. Now you see here, this RE is the radius of the Earth, and radius of the Earth is 6400 kilometer. 6400 kilometer. When you will convert this in meter, it will become 6400 into 10 to the power 3 meter. So this RE as compared to H. Okay. For example, if you want to find the value of acceleration due to gravity on the Mount Everest, okay. So we will see what will be the value there on Mount Everest. If there is some problem in my voice, suppose if my voice is cracking or something else, so you can inform me. So basically the height of Mount Everest is 8 kilometer. Height of the Mount Everest will be 8 kilometer approximately. 8 kilometer means 8,000 meter. So you can convert this into meter. So approximately it is 8,000 meter. So now this do find H by RE. So H by RE, when you will find, so this H is this 8,000 meter, or in terms of the kilometer, you can see this is 8 kilometer and this is 6,400 kilometers. So this value is negligible as compared to the radius of the Earth. So on the this, so means you can say this H by RE will be approximately equal to 0. It will this value will be in 0.000 something. So this value will be approximately equal to 0. So you can see here this value is approximately equal to 0. Means this denominator will become 1. Means G dash is equal to G. So you can see on the Mount Everest, if you will see the value of acceleration due to gravity, means on the Mount Everest there will be slight changes in the value of acceleration due to gravity. But there will be changes. There will be changes. So generally, this H by RE value is small. Generally, this H by RE value is small. For example, if suppose this H is very much less than RE, as you have seen in this case, if this is the condition, so this is G dash now. So this G dash is equal to G 1 plus. So the value of G dash, we have G divided by 1 plus H divided by RE and square of this. Now we will use here the concept of maths, that is binomial expansion. So this G dash can be written as G 1 plus H by RE to the power minus 2. I can write this in denominator, the power is 2. When this value will go in numerator, the power will become minus 2. Now we know that if this H by RE, if this this RE is much less than R, so you can say this value of H by RE will be much less than 1. So in maths, if in mathematics, in binomial expansion, if it is written 1 plus x to the power minus n, if it is written that, and it is given that this value of x is very much less than 1, so this value can be written as 1 plus 1 minus nx. Means this minus n will be multiplied with x, but the condition is that this x will be much less than 1. So here also this is the condition, this value is much less than 1. So you can write G dash is equal to G 1 minus 2h divided by RE. So this is the formula when this condition is there. So one question is there. They are saying find the height above Earth's surface where G drops to 36% of G at surface. Suppose this is the height H and here the value of G dash is 36% of the value at Earth surface, means it will be 0.36 of 0.36 of G. 36% means 36 divided by 100 and G at this particular height. And here at this point on the surface, the value is this G. So this G dash value is equal to 0.36 of G. Now, what is the formula for G dash? What is the formula for G dash? Gm by Re plus H square. Okay, this is the formula, no? For G dash. You can write this formula. For G, we have this formula. On the surface of the Earth, if R is the radius of the Earth, Re is the radius of the Earth, Me is the mass of the Earth, then on the surface, the acceleration due to gravity will be G into Me divided by Re square. So you can use this formula. For G dash, you can use this formula. You can use this formula. G is equal to G dash is equal to G divided by 1 plus H by Re square. So this G dash can be written as G divided by G dash is equal to G divided by 1 plus H by Re and square of this. And this is equal to 0.36 times of G. So from here, this G and G will be cancelled out. So what you will have? You will have 1 divided by 0.36 multiplied by 1 plus H divided by Re and square of this. So we can write this as 1 divided by 0.36 is equal to 1 plus H divided by Re and whole square. Now this, when you will remove this point, it will become 100 divided by 36 and it will be 1 plus H divided by Re and square of this. So taking under root on both sides, you will get 10 by 6 and this is equal to 1 plus H by Re. So 10 can be written as 5 and this can be written as 3. So we can write here 5 by 3. 5 by 3. And this is 1 here. So it can come here. This 1 will come here in this side. Okay. So we can write 5 by 3 minus 1. And this is H equal to H divided by Re. And 5 minus 3 by 3, it will be 2 by 3 is equal to H divided by Re. So height above the surface of the Earth, where the acceleration due to gravity become 36% of the acceleration due to gravity on the surface will be 2 by 3 of Re. So I think this option should be correct. Have you written this earlier or not, Hiba?
Yes, sir.
So now continue from here. Then we will see the variation in acceleration due to gravity when we go below the surface of the Earth. Completed? Hiba completed?
So 1 second.
Okay. So this thing you have to remember.
Cancel.
Okay. So I will give you the time for noting down this numerical. Okay. First, we will discuss the variation in acceleration due to gravity as we go below the Earth's surface. Okay, below the Earth's surface. So this is the Earth, and now we are going below the Earth's surface. Means in depth we are going. And this here we are living, and now we are going inside the Earth. Suppose here this is the inside of the Earth, and here we want to find the acceleration due to gravity. So suppose this height is h. Okay, this height is h. Now we are below the height h of the Earth. So to find the acceleration due to gravity at any point, what we do? Suppose here I want to find the acceleration due to gravity. What I will do? Means here I want to find the acceleration due to gravity. So I will take a mass m here. So on this mass m, there will be the force due to Earth. There will be the force due to Earth. Means Earth will attract this mass with weight. Earth will attract this mass with a force, and that is also the weight, that is mg. And after that, what we do? We apply Newton's law of gravitation. Means between the Earth and this body, there will be the gravitation force. That is equal to mass of the Earth into this mass into g divided by distance between the mass and the center of the Earth. And we equate both the values and we get the value of g. Earlier also we did this. Here also we did this same thing. We will do same thing. Okay, so now we are below h. We are in depth h of the Earth. So when we are finding the acceleration due to gravity here, that will be due to only this mass of the Earth, not of this mass. Okay, this mass will not contribute to the acceleration due to gravity here. Why? Because it will be like a shell. It will be like a shell, and due to this mass, inside the shell, inside the shell at any point, suppose here, here, inside the shell, at any point, the gravitational intensity is 0. So that is why this mass will not contribute or will not change the value of acceleration due to gravity here. Okay. So what we will do, we will take m mass here. Suppose m mass is placed. So on this m mass, there will be the force mg toward the center of the earth. And now mass of the earth will change. Okay, because this much mass of the earth will left. Suppose this mass of the earth is m dash. At depth h, the mass of the earth is this, and this is m dash. So now between this mass m dash and this mass, there will be the gravitation force, and that will be equal to g m dash into m divided by this distance, and this distance is suppose r distance. So you can write mg dash. This will be g dash, because here the value of the g will change. And what is weight? Weight is the mass. Weight at any point is equal to the mass multiplied by the acceleration due to gravity at that point. And this weight will be equal to the gravitational force on the mass m at that point. And gravitational force here will be g into m dash. M dash is the remaining mass of the earth, because the gravitational force on this mass will be due to this remaining mass, because we are below height h. M dash into m divided by r square. Now this m and m will be cancelled out. So the value of g dash will come out to be g into m dash divided by r square. Okay. But now this m dash we have to calculate. And we are assuming this as a uniform sphere. Uniform sphere, and this have the density rho. Means uniform sphere means everywhere the mass distribution is same. So density is constant, you can say, and density of this is given by rho. This is not resistivity, this is density rho. Assume. So we and one more thing, mass is equal to density into volume. So mass of this earth, that is m dash, is equal to density of this earth, density of this mass, okay, this mass will have density rho, and this mass will have density rho. Okay, so because this is uniform sphere, so density of whole of the earth is same. So if you want to find the mass of this part, then density of this part, so density of this part is rho. And if someone is asking what is the density of this mass, so this mass also this mass also have the same density, because density is constant for whole of the earth. So density into volume. Now volume of this sphere, smaller sphere, 4/3 pi r cube. Mass is equal to density into volume. Density into volume. So put this value of m dash in this equation. So you will get this is g dash, and density is rho multiplied by 4. What I am doing? G is g into m divided by r square. So g into m dash is this, M dash is this rho into 4 upon 3 pi r cube, rho into 4 upon 3 pi r cube. So this is g into m dash, divided by r square, and this is divided by r square. So this is r cube and here is r square, so this will be cancel out, r square, and so here there will be only r. So the value of g dash, you will get g into rho into 4 upon 3 pi into r. So we can put the value of density here. From here we can get the density. Density is equal to m dash divided by 4 upon 3 pi r cube. So we can get g dash, that is equal to g, and density is equal to m dash divided by 4 upon 3 pi into r cube and multiplied by 4 upon 3 pi r. So this 4 upon 3 cancel out, and this pi will be also cancel out, and this r will be cancel out. So here will be r square. Okay, here will be r square. So the value of g dash will be, this is also the formula you can learn. Okay. Divyangi and Hiba, is my voice cracking?
No, sir.
Okay. So this is also the formula, but this is not a famous formula. Famous formula we will get later. So this g dash is equal to g into m. This the value, when you will put the value of density rho, m dash by this. So you will get g into m dash. Sorry. Just a minute. Actually, this is also correct. This is also correct. But we want to change this formula in terms of the radius of the earth and the mass of the earth. So density is same. So density is same. So I can write this density is equal to mass of the earth divided by the volume of the earth. Volume of the earth will be 4 upon 3 pi into radius of the earth cube. And this density is also equal to this value. M dash is equal to 4 upon 3 pi r cube. Okay. So we will use now this value here. So it is g dash is equal to g, and rho is mass of the earth. Actually, now we want to convert this value in terms of the mass of the earth and radius of the earth. So that is why we are putting this density, the value of this density. So me into me divided by 4 upon 3 pi into re cube and multiplied by 4 upon 3 pi r. Now this 4 upon 3 is cancelled out with 4 upon 3, this pi is cancelled out with pi, and this r is here, r will remain here, r will be here. So this g dash, you will get g into mass of the earth. This is mass of m suffix e, okay, and this is small r, and this is divided by radius of the earth and cube of this. Basically, this formula is famous formula to calculate the acceleration due to gravity at a distance r from the center of the earth in terms of the mass of the earth and radius of the earth. Now we will convert this formula or we will compare this value with the acceleration due to gravity on the surface. What is the value of the acceleration due to gravity on surface? That is g. G is equal to g into mass of the earth divided by radius of the earth square. So from this formula, g into me we will get. So g into me will be g into re square. So we will put this g into me, this value. So the g dash value will be g into re square multiplied by r divided by re into cube. So this re square will be this re cube is cancelled out with re square. So what the value of g dash you will get? G dash you will get g into small r divided by re. Very good. So this formula we will have. So we will have again new formula, that is g divided by re into r. Very simple. Okay, first write down this. Divyangi, any other teacher is teaching you any other chapter? Yeah. Hiba, is any other teaching you
So we did thermal properties.
thermal properties?
Yeah, so
Okay. Mechanical properties finished?
in school or
No, in coaching I'm talking. Amna ma'am. Okay. 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 Scroll down.
yeah, so
Okay. So so you can write down this. Just a minute. Write down. So density is what? Mass per unit volume. In unit vol in how much volume, mm, how much mass is there in unit volume? That is density. Density is equal to mass divided by volume. So density of this of the earth we are assuming constant, but we know that density of the earth is not constant in practical life. Practically, the density of the earth is not constant, and the earth is not a perfect sphere also. We will discuss this. Okay. Okay. Complete.
Done, sir.
Okay. Now what we have done, we get the value of acceleration due to gravity at a distance r from the center of the earth. This r is from the center of the earth. Here we get this value, and we put the value of rho, and we have converted this formula in terms of the mass of the earth and the radius of the earth. And now after that we converted this formula in terms of the acceleration due to gravity on the surface of the earth. Now we will convert this formula in terms of this h. Okay, so let us discuss this h. What is this h? Okay, so this see here, if I am asking this whole value will be the radius of the earth, this whole length, from here to here, this will be the radius of the earth, and this is the height. This is the height h. This is the height h. So this r, this is small r. This is smaller, and this whole value is radius of the earth. So from here, can I write this radius of the earth is equal to this r plus h? This is r and this is h. Okay, r plus h will be radius of the earth. R plus h will be radius of the earth. R plus h. So from here we can get r. R will be re minus h. So put this value here in this equation. So you will get g dash is equal to g divided by re, and this small r can be written as radius of the earth minus h. Now this is very easy. We will divide this with this re. Okay, just tell me one thing. If it is written there 10 plus 5, and this is divided by No. If it is written there, 8 minus 12, and this is 4. You can tell this. Hmm. If it is written there, a cube minus a square, and this is divided by a. What would be the answer of this? Okay. Basically, I want to tell you now, if this type of thing is written. So what you will do, you will divide, you will write this like this. This first you will divide this a cube, divide a with a, and a square with a. Or if suppose here is not a square, here is b. So your answer will change. A cube divided by a minus b by a. This is b by a. So here also, so this is g. You will divide this whole with this re. So re by re will become 1. And this will become h divided by re. So this is another formula. Now this is the formula in terms of the h, and h we have taken from the surface. This h we have taken from the surface. G is equal to g dash 1 minus h by re. Now at the center of the earth, we will see what is the value of g dash. At center of earth. Okay. Tell me what is the value of h at the center of the earth. This h is variable quantity. Okay. H is not constant quantity. We can go deep in earth. So h will change. So what will be the, who will tell? Hiba, tell me what will be the value of this h becomes at the center of the earth if we are measuring this h from the surface of the earth.
6,100.
You can tell it will become in radius of the earth, means re. It will become radius of the earth. This from here to here, this h will become radius of the earth. So at the center of the earth, if we want to find the acceleration due to gravity, so this h will become re. So g dash will become, now put in this formula, this g, and this is 1 minus h is become re, and divide by re. So this value will become 0. So at the center of the earth, acceleration due to gravity is 0. And if acceleration due to gravity at the center of the earth is 0, means weight there will be 0. One thing you should remember always, what is weight? Weight is defined with respect to position. If you will change your position, weight will change. For example, if you are, this is earth, if you are here at the surface, if suppose you are here, so here if your weight is W1, here your weight will be W2. What is the reason the weight is changing? Because weight is mass, and mass will never change. Here is also weighted mass. Mass into acceleration due to gravity at this position. You are here this time, and here your weight will be mass multiplied by acceleration due to gravity here. Here will be mg. And what will be the weight here? Suppose this is h height above. So here weight at this position, if suppose somehow you are here. Here your weight will be mass into acceleration due to gravity here. So basically weight is depending upon position with you can say weight is depending on the acceleration due to gravity, and acceleration due to gravity changes with height, changes with depth. So at the center, if acceleration due to gravity is 0, means your weight is 0. Okay, okay, so please write down fast. Have you written this thing? Hiba, have you completed this?
Yes, sir.
And this one, this part you have to write, huh? Okay. So please write fast. You have 2 minutes. So as the chapter is going on, along with this, you have to revise also. Okay.
Done, sir.
Divyangi completed?
Yes, sir.
Okay, so please complete this also. At the center of the earth, in the next class, we will discuss the variation of G with the shape of the earth, because earth is not a perfect sphere, so shape uh, will change from position to position. So acceleration due to gravity will also change. And one more thing we will discuss, due to the rotation of the earth, the acceleration due to gravity also changes. So we will discuss that in the next class. And on the same topic, we will do the numericals also. So on this topic, there will be one numerical left that we will discuss in the next class. Completed? Okay, so we will meet now in the next class.